Hey everybody, this is Mr. Beckstrom, and today I wanted to answer a question that we had from the forums. So in this one, it says a suspension bridge has two main towers of equal height. A visitor on a tour ship approaching the bridge estimates that the angle of elevation to one of the towers is 15 degrees. Now, angle of elevation is the angle above the horizontal line. So the horizontal line is a line that goes straight left and right. So that would be above the horizontal line. An angle of depression would be below the horizontal line. So that's the 15 degrees there. After sailing 436 feet closer, so that's the 436 feet closer, he estimates the angle of elevation, so the angle above that horizontal line, to the same tower to be 55 degrees. Approximate the height of the tower. So this problem is a pretty good one to work on. It's going to take quite a bit of work, so let's go ahead and get started here. All right, so to work this one, I mean, there's a couple of different ways we could work it, but since they already gave us the partial length of this side here, I'm going to go ahead and use this entire length to try to solve this. So I'll call the remaining part of this bottom side here x. And the way I'm going to do it is I'm going to need to use both of these triangles, both the smaller triangle and then the larger triangle. So let's go ahead and start with the smaller triangle here. If I set up an equation for the smaller triangle, notice that I only know the angle here. I don't have the two pieces of information that I need in order to solve for the rest of the triangle. So I'm going to have to set up an equation where I'm still going to have to leave it in terms of variables. So that's important to know. In order to be able to solve for all of the angles and sides of a right triangle, I really need both an angle and a side. Which I don't have in this case. So the best I can do is just set up an equation. And considering I have two of the sides and an acute angle here, I'm going to be using which of the three trig functions. And that's the one that does not include the hypotenuse, so that would be the tangent, because that's the opposite and the adjacent. So if I take the tangent of this acute angle here, so let's go ahead and start with that. The tangent of 55 degrees, I can set this up 55 degrees. All right. That's going to be equal to the opposite side over the adjacent side. According to SOHCAHTOA, opposite over adjacent. So the opposite side of this angle here would be h, and the adjacent would be x. So I'm going to set that up as h over x. h over x. And now I want to solve for the height, because that's what it's asking for. So the height is equal to, multiply both sides by x in order to cancel it out on the right. So that would be x times the tangent of 55 degrees. The tangent of 55 degrees. Now notice that we still don't know what x is, so we're going to have to keep going. We have to use the larger triangle in order to be able to solve for x. So now, using the larger triangle, let's kind of do the same thing. Set up the equation. Looking at the larger, we still have a right triangle using this larger portion here. So I'm going to say the tangent of 15 degrees, so look at the larger part, is going to be still the opposite over the adjacent side. So the opposite is still h, still the h over here. Now the adjacent side is this whole thing. It's the x plus 436. So that's the x plus 436. 436. And once again, in order to solve for the h, I'm going to multiply both sides by x plus 436. So I'm going to get h is equal to x plus 436 436 times the tangent of 15 times the tangent of 15 degrees. All right. So we've gotten here so far. I hope you can read my writing. So I have the h is equal to this thing, and I have h is equal to that thing. I still don't know what x is, but since h is equal to both of those things, then I can set both of those things equal to each other. Basically a substitution. I can, since this is equal to h, I can substitute this in for this h, and then basically these two things are equal to each other. So that's what I'm going to do here. So x tan of 55 degrees is equal to, so that this is going to be equal to this equation here. And I'm going to go ahead and distribute this equation here. So this times this plus this times this using distribution is equal to x tan of 15 degrees plus 436 tan of 15 degrees. Tan of 15 degrees. All right. So now I've got this big long thing with my x's. So now from pre-calculus algebra, I know I need to get all of my terms that have the x's on one side and my constants on the other. So I'll keep, let me give myself some more room. So x tan of 55 degrees. I'll keep this over here. I'm going to take this and subtract it from both sides. That'll be minus x tangent of 15 degrees. And that's going to be equal to 436 tangent of 15 degrees. And then I can factor that x out. So pull the x out. Tangent of 55 degrees minus tangent of 15 degrees is equal to, this is quite a problem, huh? Tangent of 15 degrees. And finally, we're going to divide both sides to get that x by itself. So x is equal to 436 tangent of 15 degrees all over tangent of 55 degrees minus tan of 15 degrees. All right. And for that, we will use the calculator and get us a nice approximation for x. So calculator out. Check my mode, make sure I am in degrees. I am. And now we're going to do 436 times the tangent of 15. So times the tangent of 15 divided by, and we're going to put the whole bottom in parentheses, tangent of 55, tangent of 55 minus the tangent of 15, minus the tangent of 15. And we get approximately, and we're going to remember this is not the final answer here. We still have to get the h. So I'm going to go out here to probably like 4 decimal places. So like 100 point, and let me go back to that, 6947. That's good. So 6947. 947, and I'll go ahead and keep the whole thing in my calculator. And then in order to get my final answer, I just have to take that x and multiply it by the tangent of 55 degrees, and that will get my height here. So multiply that, so it's hit times the tangent of 55 degrees, and so that height is about 144 feet tall. So height is about 144 feet tall when you round it to the nearest foot. And that is your answer. So a lot of work there. There's probably, I don't know if there's another easy way to do it, because we really need to use this 436 length in order to do it. You might be able to do it using like law of sines, but we haven't really looked at that yet. So we probably need to go ahead and do it this way. All right. If y'all have any questions, please let me know. And I hope you have a great rest of your week. All right. Thanks, everybody.